So what do we have here? We are now 5 weeks after part 1 of my SolarEdge Energy Bank review. And this represents the key ingredient that allows us to continue with the battery commissioning and commence part 2 of our Energy Bank review. So let's get in the electricity cupboard and let's see what's in this box. Let's see what's inside this box. Okay, so this is the communications board. The procedure for replacing it, what I'm wanting to just see is that this is the same procedure that I've seen online, and indeed it does indeed look like that one. Quite interestingly, they don't put it in an anti-static bag, which I find quite surprising. So what I'm going to do is just put this to the side. So SolarEdge diagnosed that the cause of failure for this inverter was improper shutdown. That was what first line support said. They said that if you switch off the AC isolator first, then the communications board will blow up because capacitors in here will not be able to discharge. Now I'm going to say a lot more about that later on, but the proper procedure for isolating this inverter is to take this toggle switch here, set it to the off position. You need to wait 5 minutes for the capacitors to discharge. Then you need to isolate the AC, this red switch here, and then you need to isolate the DC. So we're going to proceed to switch this off, and we're going to give ourselves 5 minutes. So timer is started. A few days after my conversations with first line support, I got an email from a technical marketing manager. He had actually seen my part 1 video and he said it was excellent feedback for SolarEdge. So I made a few more videos which were very private for SolarEdge, and they provided me with technical training slides for how to commission an Energy Bank battery using RS485 instead of the EnergyNet meter. I have to say the detailed slides were absolutely fantastic, but I'm not going to show you any of them here because they are not public domain. 5 minutes has elapsed. We'll set the AC isolator to 0 and we'll set the photovoltaic isolator to 0 and we'll open up. One thing is very clear in these slides, and that is that shutdown procedure and energization procedure is very strict, and there are plenty of warnings telling you that your warranty will be void if you do not do it correctly. So you may ask, why am I doing this job? Why isn't my electrician doing this job? Well, the grim fact of the matter is that in the year 2022, everybody is simply far too busy. If I call my electrician, no doubt he will tell me it's going to be several weeks before he can slot me in. Now, given my expertise in process and safety automation systems, this is well within my field of expertise, as is configuration of programmable boards. What we have here is a communications board with several connectors, and we're going to be disconnecting each one, and we've got a Zigbee communications board which we'll remove from the main communications board. After that, we remove the grounding strip from the bottom right corner, and we remove screws from all 4 corners of the board. So as we can see, the top left corner screw is very tight, so I was struggling a bit with that one, and I was very keen to make sure I did not cam that screw out. Now, once the old communications board is safely removed, it's a simple matter of fixing the new communications board into the posts in each 4 corners, and then connecting all of the connectors back to it. Okay, so now we are ready to close this up. There we go. So now I need a drum roll. Let's turn this on. And we're getting something here. We're getting 3 LED lights, but they're much brighter. So now what I'm going to do is de-isolate the PV, and we're going to go into setup and see what we can see. So we are now getting some lights. This is much more encouraging here. So I'm still struggling to join the setup, but this is looking much more encouraging. Okay, we're connected. I'm starting to get excited now. So the first thing that happens is that we are updating the firmware. So what it will do is it will download the firmware from my phone onto the inverter. Now, the other thing to note is that whilst I'm doing all of this, we do have production. So that is, it looks like it's a sunny day outside. Yes, it's a sunny day. So now the firmware is uploaded onto the inverter. It now has to be installed into the memory. And one of the things you can see is that the lights are moving up sequentially. That tells me that firmware is updating. So this process takes about 8 minutes in my experience. Okay, so now I've got device activated as the status. So what we're going to do is continue. So we've got the blue light there, that's steady, and we've got a flashing green light. So now we go to country and language. We go through the menu. So we go to United Kingdom. Let's see where that is. United Kingdom, 230 volts. There we go. So we set that, and that's done. It's saying country mismatch. No, that's fine. So now we go up, go to monitoring communications. That's okay. That's dynamic DHCP, which is just what I want. So nothing to do there. So there's a caution here, really worth noting. When configuring the communication parameters, make sure that the on-off P switch is off. So for this next stage, we need to configure the meter, this one here. So we set it to off. So we want to go to site communication. We want to go to RS485-1. So here we are, communication. Select the port to which it's connected. Select protocol Modbus. That's what we want to do. We return to this, and then we add a Modbus device, and it's a meter. So where it says meter 1, we select that. So the meter function is export plus import. Meter protocol is what node. Device ID is 2. Okay, CT phase loss is disabled. CT rating is 100. Grid topology is WYE. PT scaling is 1. So that's it. Let's do a view status. So status is okay, and it's in an import stage at the moment, so that's fine. Minus 90 watts. Okay, so then we click on done. Now we go to the Zigbee manual. So from the communication screen, we go to smart management. So let's just have a look. So we go to communication. Okay, and then we do Zigbee protocol. We do Zigbee protocol, and then we do smart energy. Okay, so smart energy is now selected. On the manual, it says home automation, but I do not have that option here. So I'm just going to select smart energy. So that's that. So now we go back, and then it's configuring the Zigbee module. So we've done that. We return to the commissioning screen. Then we go to device manager. So we've got the smart energy manager screen is displayed. it's not, what we'll do is select a Zigbee device. No, we don't go to Zigbee Device Manager. Oh, here we are, Zigbee Device Manager. Select that, add devices. So pairing association happens, and then what we do is we hold this switch position for more than 5 seconds. Should start flashing. Yes. Okay, and then we just see when devices are detected. Nothing detected. Oh yes, we've got an item detected. That's great. So now our device is connected. That is excellent. What we're going to do now is configure the device. So we have go to the monitoring. So we go back to the smart energy icon. I have done this on here before. So let's just see this. So we've got this. So select that. Here we are. Right. So device properties, load rating, 3000 watts. Okay, and now we click on done. Then I click on this and we go to state. Does it switch on? Yes, it does. Let's turn it back off. So that tells me that this is working correctly. Okay. Let's disconnect from the, in fact, we'll do a PDF download first. So select that. Okay, so we're now good to go. So let's go onto the monitoring app. Let's select this to on. So here it is. So now we are online. Okay, hot water controller is an auto. And we've got 560 watts. And you can see that the hot water controller is sucking up all the surplus. That's just what we want. Now I've just realized we need to put export control into this. So what we'll do is go back into setup. So we go to power control. Limit control. Export control. Go back, site limit, 5 kilowatts. Okay, so that is it. We'll save a PDF. I don't know how to save a PDF. I'm pressing the button there, nothing's happened. I'll just disconnect from the device instead. Okay, so I'm going to relieve the pins and needles in my feet, and then we'll go back and we'll do the commissioning. So after I took some photographs and sent them to SolarEdge support, they diagnosed that the wiring had to be changed. Contrary to their official manuals, all of the wiring for the battery needs to be terminated on the RS485-1 connection, not the RS485-2 connection. You can also see that there are pairs of wires which are terminated on the same terminal. That is incorrect. You need to have a twisted pair with one wire on the A connection and one wire on the B connection. Furthermore, the Modbus slave address for the meter needs to be set to 2, and that's set by dip switch number 2. And you need to have the terminating resistor switched off, and that is dip switch number 7. Once I had done all of that, there was one more thing we had to do, and that was to double check the electrician's work on the main power cables, where we can check that the polarity goes from plus to plus and minus to minus. And in addition to a visual check, I decided to check it electrically as well to make sure the polarity was correct, just in case the solar panels were all installed with reverse polarity. And indeed they were not. 16 volts. And it's the correct polarity. So now that everything is returned the way it was before we started battery commissioning 4 weeks ago, we're now going to continue with the installation procedure. Now I've got a checklist and I have ticked off the things which are already good in terms of the cables. And now we've got warnings and we've got product switching on and off procedure. Now, the warnings, that they're really cautions rather than warnings. You're not going to suffer any injury here. We're not opening anything up. The cautions are that the battery must be turned off before installation, and we need to follow correct shutdown and energization procedures. So they make it very clear that any deviation from those procedures results in warranties being made invalid. So what we are going to do, we are now going to set the SolarEdge inverter to off, and we are going to wait 5 minutes. Okay, so now we've waited 5 minutes. You'll also notice that the LED lights are flashing green. There is no flashing red, which indicates safe voltage. So now what we'll do is we will disconnect the AC and we will disconnect the DC. Now let's go to the battery. So here we've got the inside of the battery. So what we'll do first, insert the connector block like so. Okay, let's screw this in. So the wiring is good. The B and the A colors are swapped around, but that was according to the technical marketing manager's advice. So he said that blue should be solid blue and A should be striped blue. I've got solid blue as being B and striped blue as being A, but that's consistent all the way through, so that's fine. Completed the wiring now, so that's correct. So let's go to page 15. So turned it off, everything is off. So now we've got starting up procedure. So we've checked and confirmed that the inverter is off completely. So now we set the disconnector to on. Okay, that's on. And then we set the P10 switch to 1. We've now got a COM light which is flashing on and off. The fault light is off. If the fault light is on, you need to set the switch to P, and then you need to confirm the fault light has gone off, and then you need to turn the battery off to 0, and then disconnect these and repeat the process. You do not switch the inverter on until you confirmed this fault light is off. Okay, so now we switch this back to on. Those were dimly lit first and then they lit up. So I think the dimly lit stage is a sort of, yeah, we'll talk about that later. We'll set the photovoltaics to 1. So now this is energized. Right, so now set that to 1. Now we connect using setup. Set this to that, then click on continue. So we're now connected using Wi-Fi. Device is ready. So we've got device manager. We found new devices. Click on that. You do not go into site commissioning. It makes it very clear that you do not do that. So we've got one energy bank. So we add that selected energy bank. So now it's going to check for a firmware upgrade. So now it's got the free firmware components that need to be installed at the bottom. And this process takes upwards of 60 minutes. 60 to 75 minutes is what it says here. You can go away and you can have a cup of tea. Here's to a good firmware upgrade. It's good. Firmware upgrades are good for tea breaks. So what you might see here is that the red light flashes periodically, and that tells me that there is firmware being updated on the serial line. So it's nothing to be alarmed about. Okay, so now the firmware has updated. It happened much quicker. I've still got a cup of tea left to drink. So we press continue here. Okay, and then what it will do is pair the devices. So we select Energy Bank. It looks like it's already done. Okay, so it's already done, I think. It didn't say start pairing or anything like that. So now we go on to commissioning. So now we go to maintenance. Okay, and we go to diagnostics. And then we go to self-tests. We go to battery self-test and we run the test. So communications is good. So now it does a charge. This whole process should take about a minute according to videos I've seen. Okay, so charge complete. So now it's going to discharge. And this cheeky sod is taking all the discharge, so it's all charging up the hot water controller. Okay, so that is complete. So now we proceed to Energy Manager. So we have got energy control. And we want to maximize self-consumption. So that is now set. So the most important thing now is to disconnect from the device. Until you've disconnected from the device, it will not update the monitoring platform. So we select disconnect from device and we're disconnected. So let's go onto the monitoring platform and see what we've got. So we have got certain things showing. We can see self-consumption on this balance here. We can see battery state of charge. We can see so that there are things here which seem to be there. If we go to the battery here, no communications, battery information, nothing. Okay, so something more to digest, I think. So we need to talk about what they suggested on first line support. They suggested that this old communication board had blown up because of incorrect shutdown procedure. Personally, I think if they're right, it's very poor product design, but I can't believe it myself. I think it's absolutely incorrect. For one thing, if the board had blown up, you'd expect to see damage caused by 400 volts straying onto an extra low voltage circuit board like this. This circuit board is rated at 5 volts according to the terminals, which I can see here. What you would expect to see when you have stray damaging voltages is capacitors which have literally blown up. What happens is that they overcharge, the dielectric fails, you get a short circuit, you get a big bang. You get scorch marks, you get bits of melted plastic. Now, I've seen this in shipyards, in equipment rooms, and I've seen this in industrial sites. It's common to happen during commissioning. Someone's wired up the wrong cables to the wrong piece of equipment. There's no such evidence of this. I've taken photographs on the front and the rear of this, and the board is in pristine condition. So before my electrician shut down the inverter one last fateful time, he had trouble trying to set the CT value on the Modbus meter. He would set 100 amps and it would automatically reset to 0 amps. And my conjecture, and it is just a conjecture, is that parameters became conflated and maybe the software became corrupt as a result. I believe this is a software corruption issue. If we saw what happened each time I switched on the inverter, the LED lights, all three of them, came on dim first for a few seconds before becoming bright. And I think that is probably the equivalent of a BIOS procedure before the main software was booting up. So I think the main software was simply corrupt. Now I entertained the idea of using the USB port here with SolarEdge support. Sadly, they didn't come back to me. I put in a blank USB stick just to see how it would react, and indeed the USB stick lit up very briefly during power on. There was no further lights on the USB stick at that point. I think if there was proper software for this, then it would may have worked correctly. The other thing you'll notice here, there's a battery. Little button battery. Typically you have them on motherboards to keep BIOS settings. I sometimes wonder why they didn't suggest pulling the battery out just to clear settings. Maybe that would have made all the difference, and it would have saved 5 weeks worth of delay in getting this unit commissioned. The other possibility that it could be is corrupt storage memory. I have had a Raspberry Pi in my loft with a corrupt SD card. I've seen automation equipment using SD cards in an industrial site, and again we had one instance where the SD card had corrupted, and in both instances we replaced the SD cards, we loaded new software onto it, and that solved the problem. Now I haven't seen any SD cards on here. I haven't seen any embedded multimedia cards soldered onto the communications board directly. What I have seen right here, there is a NAND, sorry, not NAND. There is SD-RAM memory. It's 1 gigabyte. I've got a feeling the battery is used to keep volatile memory preserved. So it would be very interesting to see where this all ends up, but I've got a feeling I won't hear any more of it. This here is going back to SolarEdge, and they will determine what the root cause is in their own way. Well, I've digested the performance of this battery since I got it commissioned. Now, the upshot is that SolarEdge has said that the monitoring platform will reset at midnight. Now, suffice to say, the battery is indeed working. What I have seen is that we can get historical data for the battery, as well as import and export and solar production. So all the data is there. Now, I used the My Energy app to have a look at 2 different scenarios, which I think is very interesting. I was cooking some chicken tonight, so I wanted to see what the profile of the battery looked like during a high load application, and there is absolutely no draw from the grid. Again, I looked at the situation in the night time after the sun had completely set, and again we're taking about 200 watts from this battery, maybe 300 watts according to load, and this battery coped very well indeed with that. What I've seen is that the battery has charged up from 35-ish% when we did the commissioning. It got up to about 70% in the late afternoon at the end of September. So the next video is going to be part 3 of my Energy Bank review. This is going to be the video which I think most consumers are going to be interested in. I'm going to be reviewing the performance of this battery, and in that performance we're going to look at maximum demand. That's a really important thing. We need to talk about safety first. I want to look at the charge and discharge profile settings that we can have for this battery. I want to look at how quickly this battery responds to a change in the load, whether there's any lag. That's really important to understand. And I want to see how well this battery copes when you're trying to charge up a car as well. One of the things I do not want to happen is this battery to drain whenever I'm charging my car. So we need to see what kind of settings we can have in the battery to prevent that from happening. So that's it for this video, and I look forward to talking to you again in my next video very soon.